I'm tackling a problem involving StratifIEDKFOLD cross-validation. I have a dataset with 100 samples, split into two classes. 20 samples belong to Class A and 80 to Class B. My goal is to create several folds for model training and testing while ensuring a fair representation of both classes in each fold. This is a fundamental concept in machine learning, crucial for building robust and reliable models. This section simply introduces the dataset I'm working with. It's a straightforward way to present the data's characteristics. This line specifies that Class A contains 20 samples. I need to keep this class balance in mind when splitting the data for cross-validation. Likewise, this shows that Class B contains 80 samples. This is the core question. I must choose the correct parameters for the _ShuffleSplit function, a tool in scikit-learn that helps me create random splits of my data for cross-validation. I'm looking for the option that ensures each fold has a representative mix of samples from Class A and Class B. Option A uses _ShuffleSplit with 5 folds, a test size of 20%, a random state for reproducibility, but crucially, it lacks stratification. That means the split may not maintain the proper proportion of Class A and B samples in each fold, potentially leading to biased results. Option B is the right choice for stratified sampling. It includes all the elements of A but also uses the _stratify parameter with $y the class labels, to guarantee that each fold maintains the original class proportions, preventing any bias. This is what we want. Option C uses an absolute number, 20, for _test_size instead of a proportion, 0.2. This is wrong, because _ShuffleSplit expects a fraction, between 0 and 1, or an integer for _train_size or _test_size to define the proportion or number of samples respectively. I'm using ShuffleSplit to divide my data into training and testing sets multiple times, making sure each class, like Class A and Class B, is represented in each split in the same proportion as it is in the whole dataset. This is called stratified k-fold cross-validation. It helps me get a more accurate sense of how well my machine learning model will generalize to new data. In this case, I'll create 5 splits. K-fold refers to this multiple splitting process where k is the number of splits. Cross-validation refers to the evaluation of the model using various splittings. I have a dataset with 100 samples. 20 belong to Class A, and 80 belong to Class B. This is important because I need to make sure my cross-validation process keeps this ratio of classes A and B consistent in each split. I am ensuring that during splitting, Class A's representation remains 20% and Class B's remains 80%. I want to find the correct way to use ShuffleSplit to divide my dataset. I need 5 splits, a test set size that's 20% of the data, and I'm setting _random_state to 42 to make sure I get the same splits every time I run the code. Importantly, I want stratified sampling, meaning the ratio of Class A and Class B should be similar across all of my splits. This one is correct. I'm setting the number of splits, n_splits the proportion of the data to use for testing, test_size and the random seed, random_state Most importantly, I'm using stratify equals y which tells ShuffleSplit to make sure that classes are represented proportionally in each split. y holds my class labels. This one works too. Instead of specifying test_size I'm using train_size to indicate that 80% of the data should be used for training, which automatically sets aside the remaining 20% for testing. Again, stratify equals y ensures stratified sampling. This one is wrong. I'm using test_size equals 20 which is an integer and not a proportion, between 0 and 1. Shufflesplit expects a proportion or another integer that represents the size of the training set. This option is incorrect because it's missing stratify Without stratify the splits won't be stratified, and I could end up with test sets that don't represent my Class A and Class B accurately. I need to understand how the parameters of ShuffleSplit work, especially the stratify parameter for stratified sampling. I'm presenting you with a question about using Sklearn SSHUFFLESPLIT function for stratified k-fold cross-validation. Imagine you have a dataset with 100 samples, 20 belonging to Class A and 80 to Class B. The goal is to figure out which SHUFFLESPLIT setup correctly creates 5 stratified splits, each with a test set representing 20% of the data, and uses random state 42 for repeatability. We'll explore several options to see which ones work correctly. This option is incorrect because it doesn't use stratified sampling. The stratify equals none part means that SHUFFLESPLIT won't maintain the class proportions, 20% Class A, 80% Class B, in each split. This is correct. This one gets it right. I set n_splits to 5 for 5 folds, test size to 0.2 for a 20% test set size, random state to 42 for reproducibility, and critically, I use stratify equals y assuming y contains the class labels. That last bit ensures stratified sampling, keeping the class proportions consistent across all splits. This option is wrong. The problem is test size equals 20 SHUFFLESPLIT expects a proportion, a number between 0 and 1, or an integer representing the number of samples for train size or test size If only one is set, the other is automatically calculated. I'm using an integer, 20 samples, which is wrong. Another correct option, similar to B, but instead of specifying test size I'm using train size equals 0.8 This is the same as a test size of 0.2, because 1 to 0.8 equals 0.2. The inclusion of stratify equals y again ensures stratified sampling, meaning I maintain a good balance of Class A and Class B in every split. This simply clarifies that the dataset I'm working with contains 20 samples of Class A and 80 samples of Class B. It provides the class distribution context for the problem. We're working with a dataset containing 100 data points. This is our total sample size. Within those 100 samples, 20 belong to Class A. This represents a smaller portion of our data. The remaining 80 samples belong to Class B. This is the majority class. Here, I'm defining the settings for the ShuffleSplit function, a tool I'll use to split my data for cross-validation. I want to create 5 different splits of the data. Each split will have a training set and a test set. For each split, 20% of the data will be used for testing, and the remaining 80% will be used for training the model. That's 0.2 as a decimal or 20 out of 100 samples. I'm setting the random state to 42. This ensures that the random splits are reproducible. If I run the code again with the same random state, I'll get the same splits. I'm using stratified sampling. That means I'm making sure that the proportion of Class A and Class B samples is similar in each training and testing set. The variable y contains the class labels A or B for each sample. Here are 4 different ways to set up the ShuffleSplit function. Let's examine each one. Option A does not use stratified sampling. This can lead to uneven splits where one class is overrepresented in some splits and underrepresented in others. Option B correctly uses stratified sampling with the class labels in Y. This ensures balanced splits. Option C specifies the test size as 20, which is an absolute number of samples, not a proportion, like 0.2. ShuffleSplit needs a proportion, between 0 and 1, or a suitable integer based on train size. Option D specifies the training size as 80%, 0.8, which is completely equivalent to setting test size to 20%. It also uses stratified sampling. I'm looking at a dataset with 2 classes, A and B. Class A has 20 samples, and Class B has 80 samples. This is important because I'll use this information to understand how different shuffle split options handle the class distribution. I'm going to use shuffle split to create 5 different training and testing sets from my data. Test underscore size equals 0.2 means each testing set will contain 20% of the data. Alternatively, I can specify train underscore size equals 0.8 meaning each training set will have 80% of the data. This achieves the same result because the two percentages add up to 1 or 100%. The key is that I'll maintain the class proportions in each split. ShuffleSplit randomly shuffles the data and divides it into sets, but the stratify option makes sure that the ratio of classes, A to B, is approximately the same in each set. This option is incorrect because I'm not using the stratify parameter. This means that the class distribution in my training and testing sets won't be representative of the overall distribution. My splits might end up biased, with one class being overrepresented. This is correct. I'm using stratify equals y where y contains my class labels. This ensures that the proportion of classes, 20% A, 80% B, is maintained in each split. The random state ensures that I get the same splits each time I run it, which is helpful for reproducing results. This one is wrong. I've made a mistake here by using 20 for test underscore size instead of 0.2. Shuffle split expects a proportion, 0.2 for 20%, not an absolute number of samples for test underscore size This is also correct. Instead of test underscore size I'm using train underscore size equals 0.8 which is equivalent to test underscore size equals 0.2 because they must add up to 1. The stratify equals y parameter means I'll still have a proper stratified split. This way of specifying the training and testing sizes is equally valid and leads to the same result. I'm asked to find the correct way to use shuffle split to perform stratified k-fold cross-validation. I need to make sure my splits are fair and representative of my data. The challenge lies in correctly using the stratify parameter along with test underscore size or train underscore size I'll explain what stratified k-fold cross-validation means. Imagine you're trying to test a model's accuracy on a dataset with different groups of data, like different types of flowers. Stratified k-fold cross-validation ensures each group is fairly represented in each testing and training split. ShuffleSplit is a technique I use to randomly split the data into different folds, and the stratified part keeps the proportions of each group balanced in the splits. It's like making sure each group gets a fair shake. I'm working with a dataset having 100 data points. 20 of them belong to Class A, and the remaining 80 belong to Class B. This is important because it affects how I ensure proper representation during cross-validation. I need to figure out which way of setting up ShuffleSplit will properly divide my data into 5 testing and training sets, making sure that each test set has about 20% of my overall data, and that the percentages of Class A and Class B are maintained in each test set. This is crucial for a fair evaluation of the model. This option tries to do 5 splits, with 20% of the data for testing each time. The random underscore state makes the process repeatable. However, stratify equals none means that the split isn't stratified. I have no guarantee that the proportions of Class A and Class B will be preserved in each test set. This is a problem. Here, I explicitly use stratify equals y where y contains the class labels, A or B. This is perfect. I'm using stratified sampling, which ensures each split maintains the original proportion of Class A and Class B, 20% and 80%. This one's a winner. I'm using test underscore size equals 20 That's wrong. Test underscore size needs to be a proportion between 0 and 1, like 0.2, not an absolute number of samples. This one uses train underscore size equals 0.8 which is equivalent to test underscore size equals 0.2 because the total size is always 1, or 100%. Combined with backquote stratify equals y backquote, it also ensures proper stratified sampling. It achieves the same outcome as option B, just a slightly different way to achieve the same thing. It's a good alternative.